one of the common applications for exponential functions is when you're dealing with compound interest. So we have two basic equations. One of them involves n compoundings per year, and the other is if you compound continuously. So the amount A equals the principal times 1 plus r over n to the nt. R is the yearly interest rate, or the APR, sometimes it's called that. N is the number of compoundings. So if they say compounded quarterly, that's 4 times per year. Monthly will be 12 times per year, and so on. T is the number of years that go by. For continuous compoundings, we have the amount equals the principal times the natural base e raised to the r times t, where the variables mean the same thing. So in number 1, suppose you invest $500 and earn 3% interest at the end of every year. So we're just compounding the interest at the end of every year. So write an equation for the amount of money you have after t years. So if you think about which equation we would use, it would be the first one, because it says we're only compounding at the end of every year. It does not say compounded continuously. So the interest is only at the end of the year, not continuously. So try to write the equation for that, and I'll put the answer up. So it's a fairly straightforward equation. We have the principal was 500 times 1 plus 0.03 is because the 3% interest rate. That's one thing a lot of people miss, is they forget the 0.03, they just put 3. So you got to be careful with that. And then divided by 1, because it's compounded once per year, and then raised to the 1t. So that simplifies to this equation here. So the next part, I want you to just use that and calculate how much would you have after 10 years. That's just a straightforward calculation by putting 10 in place of t. So you can go ahead and do that. Pause the video if you need to. You get $671.96. And then the last part here is C. It says, when will your money double? So your money doubles when you have twice as much in the account. So you'd have 1,000. So you set your equation equal to 1,000. So you solve that for the exponent t. Remember, at some point we have to use a logarithm. So what I suggest you do, get rid of the 500 by dividing by 500. A huge mistake to make in this class would be to try to multiply 500 times 1.03 and then raise it to the t. You cannot do that. You're completely missing the order of operations if you do that. So you can divide by 500. So you end up with 2 equals 1.03 to the t. Now that should make sense, because 2 means that you have doubled your ending amount. So now you apply your logarithms, and I suggest you pause the video and I'll put the answer up, so try it. So I just decided to take natural log of both sides on this one to do it a little differently than I usually do. You could have done log for the log on each side, same idea. And log 2 equals t log 1.03. Divide both sides by the log of 1.03, and you end up with 23.45. So this is one where, because you're only compounding at the end of every year, whatever you got for that decimal value there, you'd have to round up to the next full year. So I said 24 years. Okay, so that's a pretty straightforward question. Next one, same idea. We're going to take $15,000, annual interest rate of 4.2%, and find the balance after 5 years if the interest is compounded quarterly, monthly, and continuously. So that's 3 different equations. So you can pause the video and see if you come up with the equation, and I will show the answers. Again, nothing too crazy there. The one thing you do need to be very careful of, probably the most missed thing on these, is when you do the exponent, make sure you put that exponent in parentheses. If you plug in 5, 4 times 5 is 20. You can just enter it as 20, which is the easiest thing to do. If you choose to go like over here and do 12 times 5 where you don't actually multiply it, make sure that there are parentheses around the 12 times 5. So when you do exponent, 12 times 5, make sure it's in parentheses. And I'll show you on the calculator what I mean by that. So on the calculator, I have everything entered in part B, the 15,000 times 1 plus 0.042 divide by 12. And then when I get to the exponent part, I do exponent. Now mine shows the value going into the exponent. If you don't have it where it does that, where it just does the caret symbol, make sure you put parentheses and then 12 times 5 in parentheses. Okay, and that gives you the correct answer. So you have to be careful of the parentheses on that. Then on the last one, if you compound the interest continuously, how long would it take to have $50,000? So you set your equation equal to 50,000, and then you solve that by dividing by 15,000 and then applying logarithms. The natural log in this case is base e. So I'll put the answer up. I suggest you pause it and try it. So I showed a lot of steps there. The better you get at these, the less steps you can show. You should still show a few steps. So taking the log of each side, and then your exact answer, you should show that. And then your final answer here, 28.67 years. Okay, so make sure you have enough steps to show your work so I can see where your answer came from.